Okay. A hiker walks up a steep bank and then rests for a minute. He then walks up a small hill and finally across a flat plateau. What sketch of the graph could represent the elevation of the hiker? Well, look, in this initial steep climb up the bank, that's the climb up the bank. That's good. They're all doing that, all A through C. By the way, D says any of these graphs could represent it. So let's see if that's actually true. Okay, they all start by climbing that steep bank. What variables are we comparing? We're comparing the time that this person's been hiking, and their elevation. Elevation is their distance above sea level. If you are able to um, see where the level of the surface of the ocean would be underneath all of the hills and mountains and everything all around the Earth, that's sea level, where it would all be as a single level covering the Earth if there was no land there. So how far above that level would you be? Well, as you go up a hill, you're going to be getting your elevation or your distance above that level higher. So that makes sense. That makes sense. That makes sense. Now, when the hiker rests for a minute, that means that time is still passing. We're still moving along in this direction along the x-axis, but we are not getting any higher because the person is not hiking. So we should see this leveling off here. Okay, that levels off. And we see this leveling off here. So far we've got a climb and then a leveling off where they're resting. Now it says he walks up a small hill. If you're going up a hill, you're increasing your elevation. So that means that it does not any longer make sense for this one because we need to, after that rest period where you level off, you need to increase your elevation again. Okay, so we are increasing elevation here, we're increasing elevation here. So far, this one can fit and this one can fit. Now let's look at this last part after going up the small hill. Finally, across a flat plateau. What is a plateau? A plateau is like a flat-topped mountain where you can be walking on it, but your elevation is not increasing. You're not getting higher if you're walking on a flat plateau. Just a flat piece of ground just happens to be higher up than the rest of it, like on top of a mountain, but then flat. So this one, no, that's a problem because if here you were climbing up a small hill, this is continues to increase and you will not increase your elevation walking on a flat plateau. So this no longer works. It worked for here, here, and here, but at this point the hiker should be leveling off and not increasing their elevation. So we're going to say that that's not it. But it does fit here, this one, okay? Climbing up a steep bank, rests for a minute, walks up a small hill, and then across a flat plateau where the elevation is not increasing. Well, certainly it's not the case that any of these could represent that because C and B don't represent it. So what's left is that it's A. And some people say, some kids I've heard say, I don't like these type of problems, but it might be true that it's challenging, that they are challenging problems, but it's actually very helpful for you to be able to get your mind around it and say, yeah, I can see how this variable time relates to elevation in this situation and what the graph should generally look like. One big mathematical reason in further math classes is you should be able to look at your graph and know if something is obviously wrong. That obviously doesn't make sense. Like this one doesn't make sense here. Yeah, you're increasing your elevation, but after stopping, you should continue increasing your elevation. It should go up again. That should pop out at you as that can't be. Okay, same thing here. If you are walking on a flat plateau, you can't be increasing your elevation on a flat plateau, so that shouldn't be happening there. And all these things are very logical, and you want to be able to make sense of that stuff. So instead of just kind of like shutting down and saying, I don't like these problems, realize that it's simply a challenging problem that actually is really handy if you can master that skill. And so think of it as like, this is really helpful for me to know this. I don't know it now, but I could with time and with a little bit of thought and practice and asking the right questions. And always look at these things as a way of just increasing your intelligence and your understanding and once you embrace that, you're going to become smarter all the time because you accept the challenge and you realize that the payoff of it, getting smarter, is so worth it. And a lot of people are content to not continue to increase their knowledge and understanding as they go through the world. So that means that if you do, you're going to become smarter and smarter and smarter and smarter, and you're going to beat the crowd, and you'll become one of those smartest people. You can't do it by accident. It definitely takes a lot of work and practice to do it. It's just that the payoff is so huge that you should want to. Anyway, there you go.